And our next speaker is Zubair Shafiq. He's a professor at the University of California, Davis, who's going to talk to us about adding privacy to YouTube recommendations. Professor Shafiq is recruiting one postdoc and a PhD student right now. So if this topic is compelling to you, please come and talk, find him. The time is yours.
Thank you. Can you guys hear me? Yeah? Okay. So this talk is about utility preserving obfuscation approach for YouTube recommendations. This system that we call DHARPO builds on our previous work called HARPO, where we were doing privacy enhancing obfuscation, but we did not specifically consider utility, and I will tell more about that in a little bit. This work is done by Jiang and Hadi, the two students who unfortunately could not be here due to visa issues, so I will try to do the justice with this presentation. So a bit motivation. So online content platform, they necessarily personalize recommendations, and the way they primarily personalize recommendations is by tracking users, inferring user interest from user activity, and then using that to figure out which recommendations to specifically show to the users. And this naturally raises some privacy concerns. At the same time, users do actually want good recommendations, especially in systems like YouTube, where actually users care about the recommendations. So it is important to actually do obfuscation, which can hopefully preserve privacy, but at the same time preserve some utility as much as we can. There is some previous research. So for example, one of the approaches that is available, and this is a feature that is supported by many online platforms, both YouTube and TikTok, is that, for example, users can just disable personalization. It is unclear whether it actually results in any privacy improvement. So that's one. And the second issue is that it, of course, destroys the utility completely because your recommendations are now completely non-personalized. And then more recently, YouTube and TikTok, they also have this feature where you can specifically remove certain videos from your watch history. It, again, has the first issue. Yes, it might actually get rid of certain types of recommendations based on which videos you have removed. But again, it is unclear whether there is a privacy benefit. Because at least in case of TikTok, there is a very precise language which says the videos that were previously in your watch history are still being used to personalize recommendations, and only over time they will actually get rid of it. So in our group and some other groups, we have recently been working on privacy-enhancing obfuscation approaches. And specifically, we had this paper, HARPO, last year, where we designed an obfuscation system for advertising. So essentially, we built an obfuscation system which could confuse data brokers and ad targeting models. And the idea was we would essentially add fake URLs in your browsing history to confuse data brokers. And this does not rely on any cooperation from the platform, so users can independently deploy this in their browsers or mobile devices. And but the problem there is that in case of ads, at least, we made a case that users really don't care about the utility. They don't care about the relevance of the ads. That was the threat model we were working with. That is really not applicable in case of platforms like YouTube or TikTok, where users perhaps do care about the relevance of the recommendations. So hence, we have a DHARPO system, which will take HARPO, map it to YouTube-style recommendation system, then also try to preserve utility as well. So this is the high-level overview of our proposed approach. So let's suppose if there is no obfuscation. So the system model is very simple. YouTube actually collects your videos that you actually watched. We call it a user persona. And based on the videos that are in your watch history, YouTube actually recommends you some relevant videos. Pretty simple. In case of DHARPO, we have an obfuscator, which will essentially intercept all the videos that your user is watching. And as the user is watching those videos, the obfuscator will inject some selected videos into the user's watch history. So YouTube will only have an obfuscated view of a user's persona. And then based on this obfuscated persona, YouTube will give some noisy recommendations. And these noisy recommendations will be intercepted by the denoiser component of DHARPO, which will take as input the noisy recommendations, the obfuscated user persona that was given to the YouTube system, and then this denoiser also has access to the actual videos that the user watched. And this last piece is crucial because YouTube has access to these two inputs, but does not have access to the actual user persona of the user. And then we essentially denoise these video recommendations and show them back to users. So this is how we are preserving privacy, and this is how we are trying to preserve utility. So let me quickly go over the threat model. So the threat model here is very interesting because one of the big assumptions that we, after a lot of discussion, ended up making was we do not want to put any constraints on users' browsing. So users use YouTube as however they like. If they want to watch any video, no matter how rare it is, or it could be very privacy invasive, we are not going to impose any restrictions on that. And yes, our goal is to mislead YouTube by obfuscation denoising system. And we want this obfuscation denoising system to improve privacy, to preserve utility. And then since it is kind of a security paper, so our security threat model is that this obfuscation should be stealthy, because you can imagine YouTube would try to detect the presence of this kind of obfuscation system. And YouTube may even, for example, try to de-obfuscate. They may have like noisy videos that you're watching. They may try to figure out which videos are noisy, which videos are not. So we also considered that in our threat model as well. Yeah, and we have a very powerful threat model for the recommendation system. We assume that they can track they have full coverage of a user's browsing history. And then we also assume that, they are using both of those like countermeasures. They're trying to detect obfuscation, and they're also trying to potentially de-obfuscate. So this is the overview of Harpo's design. So this is so without the Harpo, user has like a bunch of videos, V1, V2, so on and so forth, that YouTube will have access to. Our obfuscator essentially takes into account, so essentially uses an embedding model that I will explain in a little bit, and then injects these red videos into the user's watch history. So essentially, it interleaves these videos into the user's watch history, and YouTube now gets access to this VO, which is the obfuscated watch history of a user. And then we get these noisy YouTube video recommendations, and then these get fed into a denoiser model, which essentially takes those three inputs that I previously showed, and then it tries to actually generate an embedding. It actually does not try to directly predict certain videos. For some reasons I will explain in a little bit. But it generates this vector, which we then essentially use to figure out which recommendations we want to eventually show to the user. And I want to, without going into too much details, at least give the basic intuition about what is our definition of privacy and utility. Like most of obfuscation papers, we are essentially trying to compute some notion of a distance between two distributions. And in this particular case, the definition of the privacy is defined by the KL divergence between the clean YouTube video recommendations that YouTube would have given us had we not had any obfuscation versus the noisy recommendations that we get from users in the presence of obfuscation. So essentially the distance between CU and CO. And the utility here basically is how much our denoiser can actually push it back, how much of the actual utility it can recover. So these are essentially our two metrics. We use KL divergence, not mutual information, for various practical reasons that we explain in the paper. And I now want to spend a little bit time about all the awesome work that the students did with ML engineering. There are a lot of like heavy lifting that needs to be done. So of course, we have YouTube videos. We need to map them to embeddings. Like what input do we use? In this particular work, we did not look at the video content of the video. We rather only relied on metadata and transcript of videos that we could extract using various APIs. And then we eventually concatenate them to come up with a video embedding. And then for our obfuscator, we essentially take these video embeddings and train a reinforcement learning agent. This is conceptually very similar to the Harpo reinforcement learning model that we presented last year with some adaptations. And then the denoiser model is an LSTM model because we have as input a sequence of recommendations that YouTube has given us. So it takes that sequence as input, combines those three inputs, and then eventually generates this vector, which is essentially the probabilities associated with different YouTube video categories. So it turns out YouTube has a taxonomy of different video categories. And we could have tried to directly predict all the output videos, but the problem here is that the universe of those videos is just like too large. And then we have a surrogate model to help speed up training of our reinforcement learning model. And then we have a bank of videos through which we use our probabilities to repopulate recommendations on YouTube. So very briefly, I want to talk about the evaluation and how did we set this up. So to evaluate this, we actually evaluated on real YouTube. We created sock puppets, and these sock puppets were trained using actually real-world traces that we got from YouTube and about 936 YouTube browsing histories of real users who were part of our user study. And then we essentially spin up a fresh browser persona. We essentially emulate the browsing history of real users, and then we go collect recommendations. And then this data set ended up being about 1 million YouTube videos in total, and we had to download them. As you can imagine, this was not very pleasant. There were a lot of issues here, but eventually over time we were able to download the metadata and transcript of all of these videos. So for evaluation, there are a lot of results in the paper, but I'm going to just primarily focus on the classic privacy utility trade-off initially. So on x-axis, we have the utility, on y-axis, utility loss, and on y-axis, we have the privacy. And if you don't do any obfuscation, this is where you are. And then if you do obfuscation, then you improve privacy, but then you also you hurt utility as well. So this is utility loss, though higher values here mean that you have lost some utility. And then there are different things that we are comparing. So there is a bias model, there is a random model, some baselines. But what we show here is if you just use the obfuscator, you actually have the best privacy, but you also hurt the utility the most. Perhaps not surprising. But the interesting result here is once we actually apply deobfuscation, the denoiser, then you notice that dharpo is actually able to recover the utility very competitively as compared to other approaches while providing the best privacy. And then there are some parameters like alpha, how much obfuscation we do, and we show that you can dial it up a fair bit and achieve very similar results. And very, very briefly, we also do the stealthiness and robustness analysis, and generally the takeaway there is YouTube cannot essentially detect it or deobfuscate it without incurring a significant number of false positives. So just to summarize, in this work, we presented dharpo, which is a utility-preserving obfuscation system for YouTube-style recommendation systems. There are some interesting limitations and future work things that I would love to discuss. First is, for example, ethical considerations. Every time we submit this work, we get some angry reviewers who complain about us violating YouTube's terms of service. And there are some ethical concerns with obfuscation in general. And then there are always this issue of YouTube can have some side channel that they can use to actually detect obfuscation, which has nothing to do with the system model, and that we consider outside of the scope. And finally, if you are more theory-oriented, you might ask why not do differential privacy based on our threat model. Unless we significantly relax the framework, we cannot really use DP. So hence, we rely on the average case mutual information-based privacy definition. And with that, I would conclude. I'm happy to take questions.
Thanks, Zubair. And Emmanuel, if you could start getting set up. We have a bunch of questions, so let's try to get through as many as we can quickly, but also you can answer in Zulip after. So Micah Schur asks, are the noisy video categories kept consistent over time? If not, is there an issue with intersection attacks where the most viewed categories can be identified as the unnoised ones?
So we right now do not consider temporal evolution, but there is no reason why the obfuscator model cannot adapt over time to as users maybe change their interests.
The next question is from Leonard Oldenburg. How would dharpo be integrated into the typical YouTube watching user experience in a mobile app? Is it a device-level proxy, or does it need to be integrated into the app directly?
So right now we have implemented it as a browser extension, so on a desktop. So on a desktop, it is actually much more doable. In mobile, at least, we were not able to find a reasonable extension ecosystem that we could do without significantly messing up with the browser or having our own browser app. And you definitely cannot integrate it in the native YouTube app. So right now, our implementation, unfortunately, only works for the browsers.
The next question is it possible that dharpo will lead to YouTube confidently building a wrong and harmful persona about the user? For example, deciding that the user has a very unhealthy lifestyle and then selling this to an insurance provider?
Yes, that is a possibility. In our harpo paper, we actually addressed this more expressly, but essentially when we had a more precise, more refined notion of utility, where a user could say, these are certain types of interest categories I don't want YouTube to infer about me. So user can actually exert some even more precise control about what they want and do not want the recommendation system to infer about them.
Okay, great. And we have time for one more. Does the obfuscator And denoise model affect the view history of users? If so, does it affect user experience? If not, does YouTube still know all the noise you inserted?
The whole point of this stealthiness is that YouTube should not know the noise that we're inserting, and it will mess up with the recommendations to some extent for the user who is actually using dharpo. But in the paper, we have this long discussion about how this system can eventually have impact on all of you as well, even if you are not using dharpo, because we essentially end up causing some data poisoning in YouTube's recommendation model as well.
Great. You have some more questions on Zulip, but we have to move on. So thank you very much again.
Thank you.